Okay, guys. All right. So on example three, let's zoom in a little bit here. Okay. Example 3A, we did A in class. Yes, we looked at that one a couple of times. Look at B. If you try to do direct substitution, we're going to have up top, we'll have 3 cubed, which is 27. 27 minus 27, 0. Okay, that's nothing to worry about. But unless the denominator is also 0. And oh my goodness, it is, because 3 squared is 9. 9 plus 3 is 12. 12 minus 12 is 0. All right, so what's supposed to happen then is you're supposed to be able to, let's go pank. You're supposed to be able to factor and simplify, or some sort of algebraic trick. All right, and that's exactly what we're going to have happen. So this is the limit as x approaches 3. All right, now you may not remember this. This is a difference of cubes, but the way a difference of cubes or a sum of cubes, both, they have the same factor and pattern. What happens is if those are both cubes, adding or subtracting, then the first binomial, you can check this with FOIL, box, whatever you want to do, will just be those cube roots. So that's x minus 3. And you're like, oh, that's good news, because that's one that we want to go away. But what's left? All right, well, what's left never will factor for you. Most of the time won't factor for you. What you do is you square the first term. Okay. You multiply these two together and change the sign. So this is kind of an algebra reminder, and then square the last one. If you were to multiply all of these by all these and combine like terms, you end up with 6 terms, of course, but 4 of them factor. Cancel. 4 of them factor. 4 of them cancel, and so you end up with the x cubed minus 27. You can check that if you like, or you can believe me. All right, and so denominator is back to just a simple one. We better have x minus 3 without even looking at it. If we don't, we can't do this one. And somebody lied to us. And I don't like lying. So x minus 3, oh yeah, and x plus 4. Okay. All right. Okay, now what do you want to write next? Well, the thing is, I think, in my opinion, my colors are just kind of crazy. Let's get some, I want like a regular blue. You're like, we're going to have to watch you changing colors. Yeah. No, not necessarily, right? You can. Oh, here we go. Yeah, just one second. There you go. That'll work. All right. So you could go ahead and say, all right, well, these cancel out, right? And then go ahead and substitute. And if you substitute, you don't have to put the limit notation. We had to have it right here, but we don't have to have it after that. And so what are we going to have? We're going to have 3 squared plus 3 times 3 plus 9. Just a bunch of 9s, right? All right, and then on the bottom, we're going to have 3 plus 4. Okay. So my numerator is 3 9s, and my denominator is 7. All right, that's fine. As an answer, that's perfectly fine. If you're trying to graph something, you'd want to know a little bit more, but that's okay. All right, so that means there's a hole in this graph, the graph of that function right there, at 3 comma 27 over 7. All right, it doesn't ask that, but good to know. All right, so I'm going to say there is a removable discontinuity at 3 comma 27 over 7. That's supposed to be over. Over 7. Okay. They didn't ask that, but I just wanted to put it. Okay, so that is example 3B.